Hi, I'm Ramy, a field engineer intern here at Wind Energy, and welcome to today's Science Short. Objects are always moving around us, from small objects, such as balls and water molecules, to larger objects, such as cars or even you and me. Most of these objects move around us every day, but have you ever wondered how they move and how we might describe that motion? Well, all objects are subject to the same laws of physics, which is what we'll discuss in today's episode. The branch of physics that helps us describe these laws of motion is called kinematics. The word kinematics comes from the Greek word kinesis, which means motion. The ticks at the end of the word signifies the study of something, in the same way one might study mathematics or semantics. Kinematics means the study of motion. Kinematics specifically focuses on the actual movement of an object rather than the forces causing the object to move. The movement of an object can be broken down to three main properties: position, velocity, and acceleration. We're going to use our trusty toy cars that you may remember from our previous episode about momentum to help explain each of these terms and how they're related. The first aspect of an object's motion is its position. This one's easy. The position of an object is its physical location relative to another point. It's how far from a starting point an object has moved. Position can be expressed as any unit of length, such as inches, feet, or even meters. Here, you can see that the car started at one place and moved forward 1 foot. The car moved a distance of 1 foot from its starting position, and this new location is the car's new position. The next property for discussion is velocity. Velocity is how fast the position of an object changes over time. You can think of it as the rate at which an object moves positions. If an object has high velocity, it's moving really fast. If an object has low velocity, it's moving really slow. Here's another example with our toy cars. This time, both cars will move the same distance, but will change how long it takes each car to get there. Each car's change in position was the same, but the amount of time the travel took was different for each of them. The blue car had a higher velocity than the red car because it took the blue car less time to travel the same change in position. Velocity seems similar to speed, doesn't it? But there is a difference. Velocity adds a directional component when it comes to change in positions we've been discussing. Let's bring back our toy cars to explain that a bit further. Both of these cars are moving at the same speed, but are going in opposite directions. That means they have a different velocity because the change in position from the starting point is different for the two cars. And finally, our last property of kinematics to discuss is acceleration. Similar to how velocity is how fast the position of an object changes over time, acceleration is how fast the velocity of an object changes over time. In other words, acceleration is the rate at which an object's velocity is changing. An object's accelerating if its velocity is changing, whether the velocity is increasing or decreasing. If the object's velocity increases, we'll see a positive acceleration. If the object's velocity decreases, we'll see a negative acceleration. If the acceleration is high, that means the velocity is changing more rapidly, like when a driver slams on the car brakes to stop. But if acceleration is low, that means the velocity is changing slowly, like when a driver takes their foot off the gas pedal and coasts to a stop. Here are a few examples of acceleration. Our toy car is starting from rest and is going to keep increasing its speed in the forward direction. At the beginning, the velocity was low, but as we move the car further, the velocity keeps increasing. So we've got a positive acceleration. Let's say our toy car is already moving at a certain velocity, and we're going to keep that velocity the same as the car travels, like setting cruise control in a real car. Because there is no change in our velocity, no acceleration happens. We're moving the car and have a velocity, but we aren't changing the velocity, so our acceleration is 0. With all of these concepts, something to remember is that they're all dependent on how you define your starting and ending points. Defining different starting points can change the values and directional components for each of these terms, so it's important to make sure that you assign the starting point where it makes the most sense. Today's installment of Wind Energy Science Shorts was about position, velocity, and acceleration, the three variables we use when we study the motion of objects, otherwise known as kinematics. If you learned something from this episode, be sure to hit that subscribe button on our YouTube channel to keep up with upcoming videos, and remember, challenge everything.